I think we're in a quite exciting time because we have a big problem. And what's exciting about it is science has always been reflective and said we have problems, but now we have a sense that there's a crisis. And what's exciting about that is we have solutions. There's solutions on the table that are being implemented, that are gradually being taken off. And an important part about those solutions, almost all the solutions, involve the publishers. So it's a change in publication practice that we need to engage in, and so it's a dialogue between editors, academics, and publishers that will make these solutions work. How do I move on from here? Here. This one, yeah. So first of all, what I'd like to do is present the evidence there is a problem. Now, the problem has been documented, especially in psychology, which I'll talk about because I'm from psychology, but it goes deeper than that, neuroscience, biomedical science, and I'm sure it extends more than that across many domains, which we'll find out when we look. As I say, scientists have been reflective and have been, essentially they've been aware of these sorts of problems and these sorts of solutions for some decades. The difference now is the intensity with which we feel the problem and the fact that the solutions are actually starting to be implemented. Now, I don't know if the term significance means something to you. In a lot of fields, what people do is some statistics, and they say the result is significant or not significant. Now, to say the result is significant seems a bit more exciting, because what you're saying is there is an effect. I'm allowed to say there is an effect. The intervention worked, there is a correlation, there is a difference. When you say non-significant, scientists have felt a bit unsure about what actually follows from that, and I'll get onto that later. But essentially, it's less conclusive. And a sense of the result being less conclusive when it's non-significant has meant that people often do not publish non-significant results. And this is what Robert Rosenthal pointed out some decades ago, so that we end up with a biased record of what the data are telling us, because the significant results get published, saying there is an effect, but there might be a whole bunch of non-significant results in which the data is evidential and bears on the question of whether an intervention or an effect exists, but they're not published. So if you look at the scientific record, you have a biased record. It might be completely misleading about the effectiveness of treatments, about the existence of effects, and so on. So this was called the file drawer problem. People would file away their non-significant results. But then the issue, I think, really took off just a few years ago, and it was for a number of reasons. One of them was this article published in 2011 by Simmons, Nelson, and Simonson. That introduced the notion of questionable research practices. So the idea here is that when you have some data, there are a number of legitimate things you could do in analysing those data. So you have some flexibility in the analysis. For example, do you put in gender as a factor in the analysis to look at, is the effect different for men or women? Do you put it in? Do you not put it in? There's not a right answer to that. So maybe you try. We'll try putting it in. We'll try not putting it in. And you can try a lot of things like that. It's not that it's right or wrong to put it in or not put it in. It's just something you can try. But the more things you can try, the more chances there are of an error. So the bigger is the probability of getting this significant result. And I think what was surprising is, where's my laser? Can't quite see that. But if you look at the, in the middle on the bottom, there's this 60% figure here. Trying just a few things that are all, some of them are more or less, legitimate in themselves, can tip you over 50-50 odds of getting a significant result, even when there's nothing there. So in other words, what they showed was you can fabricate effects out of thin air just by having a bit of analytic flexibility and trying a number of analyses until you get what you want, and then you publish that. So this showed that it's possible with existing procedures to fabricate effects out of thin air as long as you try hard enough. And this isn't fraud. That's why it's a questionable research practice. You're only doing things that are allowed. You're working in a grey area. It's just you're trying different things out. So a researcher can, in good conscience, you see, at least as it seems to them, do these things because they're not making up data. They're not doing illegitimate analyses. They're just trying some stuff out. Oh, of course we needed to put gender in the analysis because, look, it makes a difference. You can always post hoc justify. And then the question is, well, in principle you can do these things. How often does it happen? So then this paper the following year came out, John et al., where they surveyed researchers in top US universities and said, do you do these things? But they also asked, if someone asked you whether you did these things, what's the probability you tell the truth? So that second question allows you to both look at the prevalence, the percentage of time people say they have done some questionable research practice, but also estimate the true prevalence, that is, take into account whether the percentage of times a person would say they would admit to it. You see, if a person says they'll admit to it 50% of the time, there's a 50% probability of admitting to it. You can double the prevalence figures to get the true prevalence. And the sort of, I suppose, shocking thing is for these questionable research practices, you could get almost 100% prevalence, estimated prevalence. Fortunately, falsifying data at the very end here, you see, I think researchers, they're not intrinsically unethical. They don't want to do bad things. Falsifying data is rare. I mean, the 9% and the estimated prevalence there for falsifying is, I find, well, it's surprisingly high. But most of the problem comes from doing things like, oh, we tried several variables, this one didn't work, so we won't report that one. And you feel you have a good reason not to report it. Well, it didn't work, but we did get it on this variable, so we'll report that variable. You see, we're moving in this grey area of a questionable research practice. Okay, so what was established so far is moving in a grey area of acceptability of questionable research practices, you can have very high false positive rates. Established that researchers as a community engage in these in this grey area and in these practices quite a bit. Can we see the signs of it? Can we see the signs? Now, what significance means, when someone says it's significant, another way of saying this is my p is less than 0.05. This is what's often said. P less than 0.05, that means significant. So you calculate this p value, and if it's less than 0.05, you say significant, there is an effect. That's the procedure that you engage in. So these researchers then took some prestigious journals, and they looked at all the p-values in the journals, and then they found, if you look just below that 0.05, there's a little bump. You see? That shouldn't be there. That should be lying on a smooth curve. So clearly, this is the evidence that researchers had been looking, oh, my p is 0.07. I need p equals 0.05 to get published, right? Call it significance. Maybe we'll put in gender and see if this makes a difference. Oh, maybe we'll just focus on this variable. This seems the cleaner variable. This is now called p-hacking or p-phishing. You play around a bit, and then you push your p-value to just below 0.05. Now you can get it published, you see. No self-respecting editor or reviewer lets papers through with p greater than 0.05, so you push it until it's less than 0.05. And here's the evidence that is happening. So this was an important set of studies that highlighted the problem, gave evidence for a problem. Simultaneous to this, another saga was happening to do with reproducing key results. And it started out with Axel Kleermans trying to replicate a result that had become part of social psychology textbooks. It was widely cited. It had tens of thousands of citations, which said that if you get people to solve anagrams and the words that you come up with are to do with the elderly, like grey, pension, blue rinse, or whatever, then when people leave the lab, they'll walk more slowly afterwards. Okay. So this was called behavioural priming. You give people, just incidentally, without them having to think about it too much, they come across words to do with the elderly, they act like elderly people afterwards. So this appeared in the textbooks, but what Axel Clemens noticed was that no one had ever tried to replicate it. So he tried a replication, and he found he only got the effect when the experimenter knew which condition the subject was in. So at least part of the effect was an experimenter effect. The author of the original paper acted with outrage that anyone should treat his results in this way and impugn his integrity. But the outrage of the original author just motivated the community to say, right, let's try and replicate a whole bunch of these results in this area. And every direct replication I know in the behavioural priming area, except for some original results by Daniel Kahneman, were failed replications. They couldn't get the results. So I've put lots of papers, paper after paper after paper, direct replication of behavioural priming results. They could not get the results. And I think this was a sort of a wake-up call or a shock. Doesn't mean behavioural priming doesn't exist at all, but it seems a lot of the effects it was based on did not exist, or at least we have little grounds for thinking it existed those effects existed as it stands now. So was this a case of effects being built out of nothing by the mechanisms that I've just been talking about? So how much of science is, or some of the sciences anyway, are built up in this way? People p-hacking, phishing, using questionable research practices to push the results below 0.05. If you can't do that, you don't publish the non-significant results, you just end up publishing the significant results. So then this motivated what I think is an act of genius on the part of Brian Nosek, which is the reproducibility project. So what Brian Nosek said was, we could have a real problem here, but how big is the problem? We don't know until we systematically look at it. So this is what he suggests we do. Take about 100 studies published in, say, 2008, in some of the most prestigious journals, and we'll simply ask the academic community, well, which ones do they want to try and directly replicate as closely as possible. So the studies were advertised on a website. Academics then chose which study they'd like to do. They contacted the original authors to try and get the original authors on board as much as possible to say, this is the protocol we're going to follow. Is this how you did it? Is there anything else we need to know? Can we use your exact materials? Can we use your exact analysis protocol? And in most cases, the original authors were brought on board and gave their approval to the replication in the sense they said, yes, this is what we did, you're following our procedures close enough, and here's our materials, and so on. Now, whether a study replicates in the sense you get a significant result, when there really is an effect there, depends on how many participants that you run. The more participants you have, the more sensitive your study is, and the more likely you are to pick up something that is there. So statistics is about seeing through things through noise. So you can have false positives, you can say something is there when it isn't, but you can also miss out on things that really are there. So you need to run enough participants in order to have a good chance of picking up on something that is there. We can work out these things, and when I say power 92%, what that means is that they'd run sufficient participants that if there really was an effect there of the same size as the original study got, 92% of these studies should get significant results. So that's pretty sensitive. So the question is, what was the actual reproducibility rate, or what percentage of the studies replicated in the sense of got significant results? If there really had been differences to be picked up, then 92% of the studies should pick it up. If it was all chance, then given the way statistics work, the rate should be 5%. If there was nothing going on, if there were no effects at all going on, you would still get 5% significant just because we're dealing with noise. That's the way of statistics. So somewhere between 5% and 92%. 92% is good. Science is very healthy if we get 92%. If it's 5%, we're in deep trouble because it will be saying there's nothing going on at all. There's no effects there. It's all sandcastles built on shifting sands. The actual rate was 36%. For me, that's pretty shocking. There had been in preclinical cell biology research some claims of 11% and 25%, which is even more shocking. So in that context, maybe psychology is not doing so bad. But 36%, I think, is a wake-up call. It should have been 92%, right? Another way of thinking about this is not just in terms of significant, non-significant, but how big the effect is. See, significant is one thing, but how big an effect is something else. And when you plot the effect size, how big the effect was in the replication study against the original effect, if the effect size had been the same, the point should lie on that diagonal line of identity there. In fact, a rough way of describing this is they fall pretty evenly underneath that line. So even in cases where you get significant results, studies overestimate how big an effect is. And in fact, on average, your best guess of an effect, how effective is in the treatment, for example, is half what a published study claims. So this is to establish there's a problem, a real problem, and I think now, as I say, scientific communities are always self-reflective and always going on about problems. But for the reasons I've just gone through, there's a sense, no, there really is a problem. We can't just go on about there being some problem and not do anything about it. We must change. So what I want to go through now are some of the solutions on the table. And except maybe for the very last one, institutional reform, they involve publishing in some way. So first of all, pre-registration. So why pre-registration? Well, it's to do with the fact that science has had an incentive problem. What's best for science is that we do good quality research, and the quality of the research doesn't depend on the outcome. I mean, good quality research doesn't mean that you show the treatment is effective, right? Good quality research shows you whether the treatment is effective or not. So excellent, robust, good quality research might say, and this drug doesn't work. Or, and showing people words to do with being old doesn't make them walk more slowly. Okay? But what's best for scientists is producing lots of good results. What gets you published in the best journal? Exciting results. Right? What gets you promoted? What makes impact? What's good for your career? It's getting significant results. It's getting a certain outcome. So what we've been doing in the scientific community, and it's a key fault of the scientific community, is we've placed too much weight on the results of experiments, as if it's the results that matter, as if it's the results that determined how good the scientist was. As if somehow good scientists show that interventions are effective, that drugs are effective, that showing words make people walk slowly shows you a good scientist. But it's the process that produced the results that's really important. So what we should be rewarding scientists for is the process, not the results. When you reward the results, you're rewarding all of the bad behaviors that I've just been talking about. So of course they happen, that's what's rewarded. My PhD student said this to me. I feel pressurized to cheat. I feel lots of pressure to publish now these days, but I know to get published I need certain sorts of results. And this, of course, affects what editors should be doing, and therefore the sorts of policies editors should be agreeing with publishers about what journals should be doing. Editorial decisions at journals should be blind to results if we take this point really seriously. And this is what Registered Reports does, and Cortex was one of the first journals to start this. Now there's a good 20 journals that have followed. So Cortex and Psychological Science, roughly the same time, started this as an experiment. And at Cortex, we've had probably about one paper go through a month through this Registered Reports scheme. It involves the author submitting the hypotheses, procedures, and the exact analysis protocol before data collection, so before results are even known. And peer review takes place on the basis of this, before the results are in. And authors have to declare so that they do not have the data yet. Just people sometimes say, can they lie? Yes, of course they can lie. People can always be fraudulent. But as I said before, I think scientists are basically good people who try and operate within the rules. Lying is rare. The problem we're having now is not really to do with lying and fraud, although that does happen and will always happen, and we need mechanisms for that. It's to do with operating in grey areas allowed by the rules. Once you've passed this stage here, you've virtually guaranteed publication no matter what the results are. Results can be non-significant, it's still published, as long as that was a good method with good analyses, there will be a sensitive way of addressing the problem you've identified, which is an interesting problem. And this is the first paper published in the Registered Reports scheme. So now the process has come through to completion, as it were, and we're now starting to publish along those lines. None of these things matter, whether you've got a significant result, whether the results of impact, whether the results are novel, whether the hypothesis is supported. It just depends, was that a really good design with good analyses for addressing an interesting problem? But what is the evidence that pre-registration works? So, sounds good in principle. Is there any evidence that it works? Well, at least one journal has a pre-registered trial of registered reports. And to see, you see, what you might want to know is, are the results of pre-registration more reproducible when you use this method than the other method? That's an empirical question, something that can be tested. So that hasn't quite happened, although I know what I plausibly believe will be the outcome of that study, but we do need to test it. There was this paper that came out looking at, in a certain area of medicine, the number of papers that found interventions to be effective before Registered Reports was introduced in this area. 55% of medical interventions were effective before pre-registration was introduced, and afterwards 8%. I think that indicates the extent of bias and how we could be seriously misled about medical interventions or anything else in the absence of registered reports. Now, this is not the only solution, and I hope, well, more and more journals are taking it up, but I hope more and more journals do take it up. And as publishers, that's a matter for you in dialogue with editors and academics, the extent to which this happens. But there are other solutions on the table as well, which I think are really interesting, and I hope journals do take up. Here's one that was invented by physicists about 10 years ago, and I'd like to see taken up by journals in all sorts of areas. So the problem is to do with analytic diversity and deceiving ourselves because of the range of different analytic tools at our disposal and ways of analysis into thinking we have a good or right analysis because it gets the result that we want. You see, that's the problem. We're being led by the results in choosing the analysis. So in this technique, you use your data set and you add a bit of noise, you reassign labels, you transform things a little bit to make a number of data sets, say half a dozen. The analyst doesn't know which is the true data set, or even if it's there. But the analyst then works away until they're happy they have a good analysis that would apply to all the data sets. In other words, they deal with all the problems that those sorts of data show in good ways. And then you break blind. And then bingo, you have a unbiased analysis of the true data set. So I think that's an interesting idea. The best way to do that, how do you make sure that the analyst remains blind, for example? What are the best ways of creating these different data sets? Well, this is a process we're only going to learn by doing it. And so I'd really like this to be tried in lots of different areas. Here's another idea. You give the data to different teams, so it's not blind, but at least you have different teams that might have different theoretical agendas, and they all do their favoured analyses, and then you bring it together, and then you have the range of analyses on the table that different researchers might come to. Maybe this is something that can be picked up by journals. E.J. Wagenmakers from Amsterdam advocates something a bit similar, adversarial collaborations, where proponents of opposite views get together to do an experiment. They both run participants, collect data. They both agree on an analysis protocol, and then you publish together. This is a way of each proponent corrects the other in terms of bias, you see, in coming up with an agreed protocol. And it would be well combined with registered reports, but need not be. Again, this is something journals could promote and help get going. So, these publishing, different types of publishing that break the mold from what we've been doing, I think there's plenty of room to explore, and I'd love to see more exploration of these different variants to explore what might help solve the problem best. We need more publication of direct replications in prestige journals. The problem is getting editors to agree to do this. Right? So maybe this is best done in conjunction with processes like direct replications. But the best way of doing it is something for discussion, and I just think, again, something for editors and journals to be talking about. We need to publish more direct replications, but how can we do that respecting the needs of both journals and scientists? Transparency is another part of the solution. Data transparency, materials transparency, transparency of the analysis protocol and code. I've been saying for some time this is a good thing, but it's funny what motivates you to finally do something. A colleague at Cardiff, Richard Moray, said, hey, I've got this initiative, do you want to sign up to this, saying that when you get sent a paper to review, starting from mid-2016, you'll reject the paper unless the data is publicly available online for anybody to look at, or a good reason is given why not. I said, okay, I'll sign up for that. But when I signed up for that, I thought, well, I can't sign up for this unless my data is online, publicly available. So I asked all my co-authors and said, are you're going to do a lot of the work with this, you've got the data, are you willing to make our data online, publicly available, whenever we submit a paper, whether the journal asks it or not? And they all said yes. Okay. So transparency, again, some journals are doing this, PLOS, Royal Society, saying, we want your data publicly available, online, transparent, when you submit with us. Again, something more journals could do. And maybe Richard's initiative here will get this going, because if reviewers are rejecting papers because they're not being transparent in this respect, maybe it'll help the process go. And then here's a particularly strong version of this introduced by the American Journal of Political Science. When you submit here, you submit your data and your analysis protocol, and the journal then tries to reproduce your analysis. If they can't reproduce it, it's sent back to you, and it's sorted out until the journal can reproduce your analysis, given your data and your stated analysis protocol, including reproducing graphs and other such materials. And it was said in a blog that I read relatively recently, in every case they'd found some mistakes, often minor mistakes, but some mistakes. So this is a good error-correcting device, right? But transparency is not just about picking up errors here. It will focus the mind of researchers when they know their data is online for anyone to look at, pick apart, try different analytic methods. That's going to focus the mind of researchers just to be extra careful, conscientious, and try different things before they publish. Statistical reform, which is where I've personally been mainly involved. This is a time where journals and scientists are exploring different statistical techniques. And a key debate has been orthodoxy or significance testing, which I've been talking about, versus Bayes. And let me just give you a little feeling for the issue here. The way in statistics people often think about a problem is to say there's one hypothesis of no difference, called the null hypothesis, and then there's this alternative hypothesis that there's some difference. What would be nice to know at the end of collecting some data is there evidence for one, evidence for the other, or not much evidence at all. This would be nice to conclude, right? This is the sort of thing you might think we would want. Now, the trouble with p-values or significance testing is it only makes a two-way distinction. If you get a significant result, it means you have, in some sense, evidence for some difference. But a non-significant result doesn't distinguish no evidence whatsoever from evidence for nothing. But those are radically different states of affairs. So my 7-year-old, every morning before breakfast, gets no evidence all the time for all sorts of things. And if you have a bunch of data, do you know if it's non-significant? You don't know if that's just no evidence. You shouldn't use that at all. Imagine you had no evidence, you had non-significant result for side effects in a medical trial. Is that actually evidence for no side effects? No, it's not. Non-significance does not mean evidence for no side effects. So when a drug company or someone else claims this drug does not increase suicide in adolescents because it was non-significant, you don't know that from just getting non-significant results. What Bayes allows you to do, Bayesian analysis, is a three-way distinction. It allows you to distinguish evidence for nothing from no evidence. And that, in my mind, is absolutely crucial for solving some of these problems. And this is becoming more prominent. I have a website where people can calculate Bayes, or other websites like that now. JASP is being developed at the University of Amsterdam in the aim to undermine and get rid of SPSS with a freeware stats package, which is Bayesian as well as orthodox. But freeware, so people can see the code and they can see exactly how it does things. Nosek et al. In Science published some guidelines publishers might like to bear in mind in terms of how far have they gone in implementing some of these criteria. And as publishers, it would just be great if you considered all of these things and thought about what could we do to create more data transparency, more analytic transparency, more material transparency, more pre-registration, more replications. Could we get right to the strongest level here where all our journals at least have a pre-registered option, even if not everything is pre-registered? Finally, institutional reform. Part of the problem that I think that we've had in the last 10 years or so has been a change in the management structure of universities, management of academics, and more intense top-down management according to fairly simplistic criteria like publication. It used to be number of publications, at least it's not that simplistic, although that comes into it, but publication in high impact factor journals, getting grants. As I was saying, my PhD student now feels oppression in a way I never did. So now, what I used to do when I started my PhD as a beginning lecture, you'd play around with an effect, see if you can replicate it. When you felt you had something, you'd publish it. Now you feel every experiment you do has got to end up in a publication. Okay? The pressure is just more intense. And I think it's been intense according to very simplistic criteria that management just feed down directly onto academics. And one reason I have to leave after this morning is I've asked a classicist from Stanford, Josh Ober, who works on Athenian democracy, to come and talk to Brighton and Sussex universities about whether we could implement some form of Athenian democracy where academics have more control over how a university runs, so that they can make more contextually sensitive decisions about the extent to which simple operational measures define what they do. So this isn't really relevant to publishers, except for the fact I'll just mention this book by Josh Ober, who's a classicist from Stanford, who looks at Athenian democracy, Brooke Manville, who's a management consultant. They argue and have implemented in companies forms of Athenian democracy, at least movements in that direction, and argue that this can involve better running of companies. So I don't know if that takes your fancy, but it's something you might look at for your own companies anyway. All right, thanks very much.